fish network, riverine urban flood modeling, salinity intrusion studies, groundwater recharge estimation studies, modeling effect of underground oil storage structures, etc. She is one of the certified trainers for Mike software in India and has delivered a number of trainings on surface water and groundwater modeling to academic institutes like IIT, NIT, and various working professionals across India. She is also involved in the team DHI who guides and provides technical support on Mike software. So we are very pleased to have Ms. Shreya on our today's program. So now I invite her to share her talk on groundwater modeling using Feeflow. Thank you. Over to you, ma'am.
Yeah, thank you, Aishi, and thank you, Yadav sir, for your introduction. So I first of all thank SVNIT for organizing, especially Yadav sir for this opportunity. So just like Aishi introduced, I'm an engineer working in DHI India, and my name is Shreya. So I'll just start with the presentation. So followed by this presentation, like we will be also having an hands-on training practice in the next week on this software itself. So here I will just introduce you what is the software and like how you do the recharge estimations or the recharge studies, how some studies which we have done using the software, just few case studies example. So it will be a very like not very it's a compact presentation, basically not a, like very detailed one. It's a brief presentation on modeling as well as the applications of the software. So I'll just get into my presentation. So I hope my screen is visible.
Yes, ma'am.
Yeah, thank you, Aishi. So let me introduce our company first before getting into the presentation. So we are a company which is actually a not-to-profit organization where we have half of it like we are mainly engineers who have MTech and BTech degrees with 30 offices all over the world. So we have consultancy wing as well as we have a software sales wing which is called the Mike Softwares basically. So we also work a lot with academic, especially the students. A part of our wing is called Academy Wing, which is the one which delivers all these trainings and tutorials to the students as well as guidance for the theses and such things. So this is a brief idea about our organization. So this is the agenda which I have planned for the day. So I'll just give you an introduction and then we'll get into groundwater modeling, and we have this tool called Feeflow which is being developed by DHI only. So some case studies on how we have studied using Feeflow on the recharge estimations and effects of rainwater harvesting basically. So this is the basic idea of my presentation. So as I heard from sir, it's the fifth day. So you have already got like a better idea about what is rainwater harvesting. Like normally everybody knows what is rainwater harvesting basically. So here I just added two parts of rainwater harvesting, like two main techniques usually we have is one is the easiest way, that is storage of rainwater on the surface, which is being directly used for our purposes using filter. After filtering you just use it directly, maybe a tank storage or something is there. So from the rooftop or something you filter it and you give it to the tank, and from that you use it for your purposes like car washing or clothes washing, such things. So that is one method. The another thing which is the recharge to groundwater. So you can see from the filter it's going to pump and the leftover is being recharged to a well, and from there it is a shaft or a well, a injection well or something. From that it will be going to the groundwater. So this is one of the best technique for recharging our groundwater. So in coming case studies which I would be presenting, there are examples where this groundwater recharge have helped the help in improving the groundwater depletion, as well as how the water quality in the region is also being improved because of groundwater recharge. So this is one of the prominent technique which we use for sustainable water management, as well as to improve the quality of your aquifer. So it's one of the major mitigation measures which we use, or we tell our clients. We have worked on few projects where the quality deterioration or the recharge estimation was done, and one of the main suggestion which we provide that them was this rainwater harvesting technique, so that their groundwater recharge is also taken care of. So we have also experienced that this has also improved the quality of water in that particular region. So this is the two main techniques. So I will be more focusing on this recharge to groundwater, since my topic is basically groundwater modeling. So this is two examples. Like, you usually know, this is your tank. So from the tank you have the supply part, then this is the recharge to groundwater. So you can see the shaft over here. So this shaft, either it can be an injection well kind of one, or you have a check dam kind of recharge structure. So there are different options for that. So here, this is one method which is normally used for recharge to groundwater. So we will be focusing more on this shaft kind of structure. Then, as you know, the title of the talk is basically groundwater modeling. So, why do we do groundwater modeling basically? So, usually you can see like what is going to happen if you do something. For example, groundwater recharging. If you do the groundwater recharging, what is the effect in the future? So, if you want to predict that, like the forecast after 10 years, if you do this much recharge, what is the amount of water that can be available or made available in your aquifer? So if you want to study the prediction part, it's better you go for a groundwater modeling study. Similarly, based on the data or the rainfall details which you have, you can study like what is the present condition of your aquifer, and like you can predict like in the future how much depletion or how much lack of water we will be having. Thus, we will get an idea about how we have to manage the water in the aquifer, what is the possible ways to do the sustainable water management basically. So that's why we do this modeling. So basically the idea for modeling is to understand, like if you construct a particular structure, what will be the future changes, or what is the positive or negative impact that is going to happen into my system. So to understand that, you basically do this groundwater modeling studies. So also another good thing about this groundwater modeling is sometimes you may not have the data set for entire region. So there is a technique called inverse modeling technique, where you can predict this is the possible or the possible conditions in my aquifer right now. So this helps in improving your like future when you take a management decision. For there is decision support tools. So this groundwater models can act as the basis of your like decision support tools. So you can understand like in the future what will be the condition. So accordingly you can take the decisions for the future, and as well as you can like tell what is the a possible condition. If the water precipitation reduces by this much amount, what is the possible conditions in your aquifer? If it increases by this much amount, what is the possible condition in your aquifer? So if quality component is there, like how the quality increases or decreases with recharge. So such things you can improve or study using this groundwater modeling structures. So this is the basic idea of groundwater model. So you can see here, the first one is the reality. That is, you have a real condition. You have a field condition of like a river may be there. There will be mountains or hills or valleys. Many things will be there. Then the soil will be different from one place to another. So in this reality, you will have this term called abstraction happening. That is, pumping may be one reason for abstraction, or there are evapotranspiration. Many other natural reasons also happens, which takes water from your aquifer. So now after you have this reality in your hand, you conceptualize this reality to a model, that is the conceptual model part. So conceptual model is basically like whatever you have in your field condition, you have to replicate in your model, whichever model it is, whichever groundwater model it is, you have to replicate in that particular model. So in the conceptual model part, you basically add all the riverine features or the plants or the land use pattern, or what type of soil it is there, what is the weather condition existing there. So these all are the input. So this planning stage in the model is called as conceptual model. So once you conceptualizes it in the model, you do the representation by some equations, that is your mathematical models. So even in usual Darcy's law equation, that is if you are using a saturated model, you will be usually doing as your Darcy's law equation, or Darcy's flow will be the one which you will be considering. So you have a mathematical equation to explain these conditions. Then you can see the simulation part, and you can see this numerical model here. So in numerical model, what basically happens is, in each of this grid or each of this meshes, a particular equation. So here our equation will be this Darcy's law equation. So that equation will be solved in each of these grids or each of these nodes. So accordingly, you get the water level changes in this particular study region, or whatever is the like hydraulic head variation or contaminant variation will be based on the equation which is being solved there. So that is how you see the spatial and temporal variation of a particular component, even if it's a water level changes or whatever changes, it's you get the spatial and temporal changes. So basically in the groundwater model, you represent the reality on field and use some equations. So these equations will be solved in each of these grades or each of these points in the mathematical model, and from that you get the output. So this actually helps us in one way, is that you can know the present as well as you can also predict the future, what is going to happen in the future. Thus it helps us to understand, like in the future this is going to come, so to control that, what all can be done. So a sustainable water management can be basically practiced if you have a good groundwater model. Also another good thing is, like you have an underground construction happening. So if you have an underground construction, there may be seepage occurring, or like some changes will be happening to your aquifer system, so the flow pattern will change. So how can that be accommodated in the aquifer? How will it impact your aquifer system? So if you want to study those things, it's always better you go for a groundwater model. So this is the basic idea about what is a groundwater model. So just we have this tool called as Feeflow. So since we are going to train it on Feeflow, I'll just give you an idea about what is the use of Feeflow and what all the application for which it is being used. So Feeflow, why the name is basically, it's a finite element flow model. So finite element is the method for solving a partial differential equation. So whichever partial differential equation is there, so here it is using the finite element method to solve that particular equation. So mostly here it will not be grids, here it will be your triangular meshes will be used. So in each triangle an equation will be solved. So based on that you get the head variations in your study area. So it's a software which is basically used to solve flow, mass and heat transport equations. So also we can use it for studying the groundwater age studies also. So this is actually the development or history of Feeflow software. So initially it could only do the 2D model analysis, but right now it is capable of doing the three-dimensional analysis, as well as there is like this integrated surface water groundwater modeling you can do. Also you have some advanced three-dimensional modeling like the unstructured meshes you can do. Then it also has some Python interfaces. So these are the development stages. So actually in 2022, recently we have released the Feeflow 8.0 version. That is an advanced version of the software. So these are the applications of the software. I haven't included all the application, like a basic application, which will be of use to us. Only I have included here. So you can see the regional groundwater management. So I have plenty of studies having done on this topic, like the management of artificial recharge method. So if you have a check dam, like how does that impact your groundwater basically? So such studies we have done a lot. So similarly, you have irrigation. So the water is being taken for irrigation, how the depletion is being affected in the groundwater. So dewatering systems, like the interaction with surface and groundwater. Also groundwater recharge estimation studies, like the water balance studies. So this is another software feature, like this captures on delineation. So you can see here, so how water flow occurs from a particular structure, or in a like for example, you have a well here. To that well, from which all direction the flow can come in. So such kind of studies you can do using this regional groundwater management option in the software. So another thing is groundwater quality studies, like you have a seawater intrusion case, like, or if you have some contaminant transport case, maybe a multi-species, or any kind of contaminant transport studies. You want to study that, or you want to study the nuclear waste storage, like that. For that, you can basically use the software for. Then this is the geotechnics and the porous media aspect, where you can study due to pore water estimation. Like this consolidation of soil basically happens whenever there is pore water. When it expels, there a consolidation happens. So to study such things also, you can use the software for. So it can be used for saturated as well as unsaturated zone studies. So different models are available for that. So these are some of the applications of the software. Also, not only to actually, this model studies are basically done for a large scale. So basically, for a large area scale, we do the study, but we also do study for like smaller, like porous media materials. For example, you can see this. Pampers, for example, Pampers, they are one of our main customers. Not they actually study the seepage, like the seepage through this layers of this Pampers or napkins, basically using this particular software. So the range of software is like from a small, very small scale to very large scale. You can basically use the software for. So now I'll just get into the conceptualization part. So basically, till now we were just telling what the software is and what are the applications of the software. So in the model conceptualization, basically you can see here the first thing is basically conceptual model. That same thing is here called as model conceptualization. So here in the software, what it actually does it, like first stage is called as a super mesh stage. That is super mesh preparation stage. That is like, you tell in your study area you have a river, or you have a well, or you have any other structures. So that stage of planning, like whatever is there in the field, you are taking that into the model, is called as conceptualization stage. So here you have this options like points, lines, and polygon, which is used to identify these features in the model. So lines basically are used to, like simple rivers are there, then you use a line structure to define that particular river. Or else you have a like for example, agricultural field is there, so that region will be defined using a polygon feature, or your model area boundary will be defined using a polygon feature. Similarly, you have wells in your study area, that will be depicted using a point feature. So these kind of depiction, like telling the model this is a point, or this is a well structure, or this is a line element, or this is a polygon element, is basically the conceptual stage. So there you plan like what all are there. So why we are doing this planning is basically because in your model you may need some regions like more number of meshes, some region like finer mesh, coarser mesh. This is one topic which we usually use when you talk about modeling. So finer mesh means if you have a more number of elements, that is called as finer mesh. Like more number of triangles, that is called finer mesh. So more number of triangles means more number of equations will be solved there, so your result accuracy will be more there. But it's not necessary you give this more number of elements in all the locations. So that like flexibility, to choose where you want to give like more important, where you want to give like less importance in your study area, can be done in this particular conceptualization stage. So that is why we do this aspect called model conceptualization or super mesh in the first part. So after super mesh only, you will be telling here I need more number of elements, here I need lesser number of elements. So from this only you convert it into a mesh, and this mesh is used to give the data and input parameters etc into the model, and you will be running your simulation. So the first stage of super mesh or modeling conceptualization is called a super mesh in Feeflow software. So you can see here, this is the workflow. So your concepts are first one. So you can actually mark like each region. This is an example of a open pit mine in a study area. So you have your model area boundary. So you can see these lines. These lines are used to depict the fault or fractures in the study area. Then you have this you can see different colors, right? So these different colors represents the material regions. So you tell the model this is the different material regions, or these are the properties of this material regions, and you tell this lines represent what feature, like a discrete feature is called as a fault or a fracture network. So such conceptual part is basically done in the conceptualization option, and from this concept you will be generating a mesh. So this is a mesh. Either you can go for a two-dimensional mesh, or you can give the elevation data and everything and go for a layered three-dimensional mesh, or you can go for a partially layered mesh or like fully unstructured mesh. So these are the options. So first you conceptualize what is there. So based on that, model will create, you add the elevation data, you create the 3D FEM mesh, that is 3D finite element mesh. So this will be your model. So once your model is ready, you will have to add the data sets, like your whatever data set, whatever like the rainfall or whatever it's there, you will have to add that into the model. So here you have this geological aspect. So always your geology is one thing that makes the things complicated basically. Sometimes you will have a very simple geology in your study area, but sometimes you will have many fault network, many fracture networks etc in the study area, which makes it difficult to model the study. So here we have this model where you can actually create mesh like this. Inside the mesh you can actually add your fault or fracture networks inside that. So this video actually shows like how the fault or fractures are actually there. So this is your basic thing. So if your geology is done and your material properties are given properly, then accordingly you will be able to develop your model, and you will get a better results accordingly. So this is the thing. So this is the basic idea. So first you conceptualize, then you create a mesh accordingly based on your concept. So now our topic is basically the recharge or the aquifer. So this is one important aspect. So as groundwater related studies, the one of the main aspect is the amount of water available in the ground. So for proper groundwater management, groundwater recharges have one important aspect. So we do like the rainfall harvesting or rainfall recharge methods are basically like additional methods like the artificial recharge structures which you will be adding on into the field. But through the nature itself there is like many recharge happening. Basically your for example, you have a surface water, so you have a river or something in your study area, so that can also act as a source of recharge. So you know the surface water and groundwater interaction. So if you have a river in your study area, so that can also act as a source of inflow into the model. So similarly in this particular river, you can add an artificial recharge structure, for example like a check dam or something. So that can also help in improving the water in that particular region. So this is another study where we have actually linked a recharge with Feeflow, and we can actually get the variation of a recharge occurring, like how much is the variation of recharge occurring in the study area. And based on this, we can, like, this is in the present condition, in the future what is going to happen in the future, how much is the change in recharge occurring, like based on the, maybe you have some predicted rainfall with you. So based on that, you can tell like in future what is the condition. Also, there are some decision making support tools basically, which can be used to predict in future if rainfall increases this much, this is the possible changes in recharge, this is the possible water available. So accordingly, you can model the groundwater fluctuation. So you can see here, this is actually the rainfall, and based on the rainfall, the water level changes. So you can see this head elevation changes in the saturated zone. So this basically help you understand how the water level is being changing in your study area, in your location. So you can just understand like how it is being depleted. So if it's depleted, how can you like create the proper management aspect, or you can create the mitigation measures. So this is one good thing which you can actually visualize. So you can just see how it is. So you can see here, whenever the rainfall amount is decreasing, here the fluctuations are also being shown here. So these are actually isolines showing the water level, that is head and in the saturated zone water level, basically that is our groundwater zone water level. So whenever there is a fluctuation in the water level, it shows here how the water table is being fluctuating. So that is one good aspect about the groundwater recharge studies. So this was one study which we have done using the software. So now I'll just go into few case studies like which we have done on the effect of groundwater recharge. So this is one study, like this is actually a seawater intrusion study where this is actually in Cochin region, Kerala. So there we had this study area. This is 1,000 square kilometer of study area we were doing the study for. So you have this like sea region over here. So there were these points which you see here are actually the well regions. That is like the pumping and observation wells regions in the study area. So we actually try to simulate the fluctuation, like what is the sea water intrusion happening into this particular region. So this was done for a 50-year period, like in the prediction part was done for the 50-year period, and it was predicted like it was around maybe 3.8 or 4 kilometer of intrusion is being predicted in the region. But so to just understand what can be the possible mitigation measure, like how can we reduce this particular intrusion effect in the region, we just these three wells which you see here, like Fort Cochin, Kadava and Shellanam, were showing some fluctuation. Like in Fort Cochin there was not much intrusion, but in Kadava and Shellanam region the intrusion rates were so high. We just tried to like understand, like if we are giving the w- recharge, like rainfall recharge, like a artificial well structure is being aligned here, and if we are doing the recharge over here, how does that fluctuation basically happen here, like how much is the how much will be the concentration change happening here. So this is basically a study, like for a year we just simulated it, like for a year period. So initially we were just simulating for the same period with a concentration recharge of like about 10 percentage. So that is like the rainfall was changed to like 10 percentage recharge, like the GEC committee report. So we just consider like 10 percentage recharge only was happening in the region. So to understand, like if we increase the recharge in this region, what will be the situation, or what will be the change, we just added a concentration of like recharge of like about 50 percentage. So we just tried to understand how there is fluctuation. So there was like good change in actually the level of this seawater intrusion, or the like the concentration of contaminant in the region. So the concentration levels were basically changing whenever we added an artificial recharge structure or artificial recharge method over here. So we could change it to like a considerable level basically. But in Chelanam region, even if you see here, the shift is like a bit less, because it's actually like almost in the sea, like sea was coming towards the region. So uh, like it was getting intruded more, so that's why we couldn't expect more change here. Also there, it's very near, like actually in this region, this is actually below the sea level, so the intrusion part was actually more here, so that's why you can't see much change in the Chelanam region. But in other regions, we can actually bring down, we could actually bring down the in concentration levels considerably. Also this study was just to understand like the water availability and things in the region, and it was seen like if this kind of structures like the recharge mitigation measures that followed over the entire region, in this particular region, like the rainwater harvesting structures or rooftop rainwater harvesting and using it for recharge, this would improve the quality of water in the entire region. Actually here, the water being used is from the water department only, they are supplying the water over there. So if every house, if they start this rainfall recharge or rainfall harvesting and use that for recharging the aquifer, it was seen that the depletion of aquifer can be improved, like more water will be available for the use of people. So usually intrusion happens whenever there is like whenever your water table goes below your sea level basically. So if you increase your water table over this region, then it's sure that you can reverse this condition existing there. Similarly, we also understood that like if every house, if you are using a recharge structure over there, the aquifer can be improved to a large extent. So this is one thing, that like not only the water level depletion, also recharge, rainfall recharge basically helps you to mitigate the issues like the contamination issues or the seawater intrusion issues can be reversed if you are recharging your aquifer or improving the amount of water in the aquifer. So this is one like image where you can see the seawater interface basically. So this is actually your seawater side. So this region, this is a cross section view. So there more intrusion was happening into this particular region. So we just added this 50 percentage recharge condition. So you can see the change in the concentration levels over here. So here the concentrations were so high, while as you see here in this file, it is getting neutralized due to the effect of rainfall. So this is one good thing, like even as you even like in monsoon seasons, the rainfall, whenever there is rainfall, if you could use that for recharging your aquifer as well, this can improve not only the water level depletion, it can also improve the water quality of your aquifer. So this was one insight which we got from this particular study. So this is another study. So this is in Chennai. So there, this river, Chennai is one city which faces water issues a lot. So water is less. Very scarce in Chennai actually. So we get rain through cyclones and everything, but the issue is all this water just run off. So we get urban flooding also. So that is one issue which Chennai faces. So this is one such study. So here you can see this is the pathway which was used here. So we have the climate data, then we had the surface water model. So in the surface water model, we have considered a MAR structure for recharging the groundwater. So similarly, Feeflow was used to model the groundwater aspect. So this was coupled with Feeflow. So you have a surface water and groundwater model coupled. So this is a sea water intrusion study also. So here, based on the coupling, what results were observed is that, like you can see these lines. So these are basically without check dam and with check dam, and with increase in crest level of check dam. So this shows like how this is the interface basically where the intrusion is actually there. So the extent of intrusion shifts like whenever there is a check dam, like the water recharge occurs and the depletion is reduced. You can see the change in the level, like you can see the seawater intrusion levels being changing over here. So this is another case study which shows us like how modeling helps us to see like what is the possible structure which can be constructed, like what is the good thing happening if you add a structure over there. Sometimes even if you add a structure over here, you may not get some like reasonable effect over there. So you just do modeling and you can understand like what is the possible, like whether it's good to add there or is it bad to add there. Sometimes if you add a structure there, you get the reverse flow there. So sometimes you add it, there may not be a use. So in that case, it's not like you don't have to waste your money like or effort in that condition. So modeling helps you understand these things, like in the future what may be the condition if you are constructing a particular thing, or if you are removing a particular thing, what may be the changes. So this is another study which we have done. So this is a study in Berlin basically. So in this region, it was a groundwater recharge estimation study. So it was used to understand like how the groundwater levels are decreasing. So so in the region there like due to reduction in the rainfall, so how much is the water available. So water availability study was done, and the levels, how the levels in the region is changing. So due to recharge, how much recharge is changing. So this was a model which was developed. So this shows the average groundwater recharge for the study region for the period 1961 to 1990. So this was the base model which is used. So from this base model, they built a model with the futuristic rainfall estimations and everything. And so, like in the future, like in 2051 to 2060, there will be a drop of 22 to 30% of recharge. Comparing to whatever is it here, there will be a variation of like 22 to 30% of recharge in the study area. So this was another study which we have done. So this is a image which shows the recharge pattern. So this was also done using modeling, where you can see how the recharge fluctuates during the wet session, and in the dry session what is the total recharge happening here. Similarly, like in the future, what is the possible condition. So all this shows the importance of recharge in the region. So as part of this particular study, we have given some ideas to the water management community. So they just understood like these are the possible things to happen in the future. So if this much deficit comes in, like we should take proper measures to improve the quality of water or the quantity of water, or avoid depletion in the region. What all we should do here. So basically modeling helps us to visualize like what is the impact of reduced groundwater recharge in your study area location, and what strategy can be used there. So here we prepared a water retention strategy, and also like analyze what will be the effect of two artificial groundwater recharge in the areas. So this actually improved the quality of recharge and also the water levels in the study area region. So these were the base benefits which we got from this study. Not only this study, there is like a few studies which we have also done for some private clients, which where we have also suggested them to have this groundwater recharge structures over there in their location, since the water availability was very less there. So we also tried to understand like if this structure is being constructed, what is the possible recharge occurring there, and in the future what will be the condition. So all this showed us like the positive impacts, like if a structure is over there, like this much recharge is possible there. So these are some of the benefits or good things which we have like analyzed or studied during the period of these projects, which shows us like how good such, since groundwater recharging or this recharge artificial rainwater recharging is a method which is very sustainable method, and this can be even our rooftop rainwater harvesting. Like you can create a shaft and just use it for like recharging your groundwater. In every household, if you have that, it would be like recharging the aquifer to a large extent. So this would always benefit in the water quality as well as quantity of the area. So this is just the conclusion part. So what we have felt from our studies using the software is that like the it is rainwater harvesting is one of the best technique which can be used for sustainable groundwater management. It not only replenish or like recharge the aquifer, but it also like improve the quality of that aquifer. So as Feeflow as a tool, what we have felt is like we can also model the impact of climate change on groundwater, as well as like we can use it for the mitigation, like if a recharge is there or whatever conditions are there, like what is the positive effect it can create in your like groundwater, or whatever condition it is, what is the possible positive thing that can happen in the region. So it also showed us like rainfall can improve the groundwater levels as well as quality of the region. So that's a very short presentation from me. So like if you have any queries or questions or comments, you can just put it forward.
Thank you, Shreya ma'am. It's a very good presentation, though you are saying it short, but it has covered so many things. And if somebody wants to carry out any of the case studies, probably he may need 6 months of time or even more than that to carry out such analysis. Let me inform participants that Shreya is the trainer for DHI group, and she not only she is trainer, but she is solution provider to DHI software, whether it will be a Feeflow, whether it is a mic series. So any software of mic series or Feeflow, specifically groundwater modeling and groundwater studies, that specifically for that, the Shreya ma'am has done her work in that particular area, and she is probably the only trainer in DHI as far as the groundwater modeling is concerned, if I am not wrong, ma'am.
Yeah, I used to
Yeah.
give. Yes.
Yeah. So there are 2-3 quick questions. We will take
Yeah.
it up first. What is the advantage of Mike She over
Mm.
Feeflow for groundwater modeling?
Yeah. So, Mike, this is a question I always get whenever I go for any training. So, I am used to answering this question. So, Mike She as a model, like it can be used. Usually, we use Mike She for the shallow aquifer regions, basically. So, shallow aquifer regions like Mike She can accommodate both your surface and groundwater interactions, and also your shallow aquifers, basically. But if you have a complex geology, or a complex geological condition, or it's only groundwater, so all the details of groundwater, all the aspects of groundwater, you have a fault network or you have a fracture network or whatever in detail it is there, you can add Feeflow also to that. So that is the main difference. Complex models we usually go for Feeflow, like the deep aquifer analysis, it's usually done in Feeflow. Mike-She is used for shallow aquifer conditions. Similarly, if you want to do like seawater intrusion studies, Mike-She cannot do that. Seawater intrusion studies that can be accommodated in Feeflow. So this is the basic difference between both the softwares. There is an integration tool between Mike-She and Feeflow. So if you are doing in Mike-She shallow water, then you want to combine it with Feeflow, there is an integration tool. You can directly couple both the softwares also. So that is for very detailed groundwater analysis. So I hope it is clear.
There is a second question. Can seawater intrusion be checked to some extent with a surface dike near the sea coast?
Yes, so you can do that. Like if you have a surface dike or like any condition, you can create that structural geometry. This is the difference basically between She and Feeflow. Here you can do the geometry as well, like whatever is the geometry of a particular structure, you can add that also, and you can just see like what is the impact over there. That can be analyzed very easily. You can do.
Next question is, in this software, shall we get the 3D model for groundwater contamination through leachate percolation?
Yes, you can get that. Like it's basically a 2D and 3D model. So we usually work on 3D part. So you want to see the leachate modeling or the plume transfer or whatever it is, you can use Feeflow for that. 3-dimensional modeling can be done.
Can we model contaminant quality and transport study?
Sure, you can do that, contaminant quality. And there is this module called Feeflow FM3, that is mass transport 3-dimensional model. So there you can actually do the contaminant and quality transport. So I guess if same people will be attending the like the hands-on session, then we
Yes.
will be covering this in the hands-on part as well.
Also, ma'am, if you can tell them that what is the requirement for hands-on session, that will be fine for all the participants.
Yeah. So only requirement is your laptop. So I guess you have to bring your laptop with you. So for the laptop, the configuration is basically your normal like 4 GB RAM, 64-bit laptop. Only Windows 10 professional it should be. So Windows 10 or 11 professional, whatever it is, that's the only requirement which is required. So the license and everything, I'll be providing that for the training. So only this is your laptop, you should take care, that's it. Or else, yeah, that's the only requirement. Other things we can check in during the training. Installation part and all, I will be guiding you before the training part, like maybe a day before that I will send you the installation links and everything. Or if you need an installation training also, like we can arrange a session for that as well.
So I think your session is on 14th, ma'am, or 15?
15, no sir, 15.
1 minute, I'll just check it. I have opened it. 14, 15. Yeah, it's on 15.
Yes.
It is from 2 o'clock to 5 p.m. 2 to 5 p.m.
Okay.
Okay. So
Yes.
shall we arrange the session for installation on the same day or one day before it?
Yeah, whatever is convenient for you, that's okay for me. Like even
Okay,
if it's
what I will do, I will message you in case if all the participant will say, because they have to carry the laptop. So if they carry laptop on 15th only, then we can do it on 15 itself, no
15.
problem.
Yes,
right?
yes.
And if they are carrying daily, then probably we can do in advance also.
Yes, yes,
Okay.
sure, sir. No problem.
Anybody have any another question, please? Anybody wants to discuss anything with ma'am? So if there is no question, then thank you very much.
Yeah, thank you, sir. Sir,
you.
I guess you are muted, sir.
Yeah, sir. Thank you very much for your session. Very informative. At the same time, the participants have got idea that there is a specific software for groundwater modeling in which we can even combine the recharging. And as during the session, you pointed out that how much amount of water you are recharging, and because of that, what is its impact on groundwater. That also it is possible to study. And probably up till now, no one has carried out this specific type of a study wherein the rooftop rainwater harvesting is model for groundwater, specifically how it is varying in both quantity and quality. Thank you very much, ma'am, and see you on 15th. Okay.
Yeah, thank you so much. Thank you so much all for this opportunity.
Thank you, ma'am.
Yeah, we'll meet you on 15th.
Yeah, ma'am, sure.
Yeah, bye.
Thank you, ma'am.